Welcome back to the flipped classroom. Our topic today is laws of logarithms, and let's not be afraid to tackle these laws today. Okay, so here they are. There's only 3, and our first log property, we're going to label in our notebook as law 1, and we're going to refer to this one as law 1 throughout the next couple days. So you notice law 1 says that log base b of m times n is equal to log base b of m plus log base b of n. So basically what we did is we separated the m and m, we gave each one a separate log, and we put a plus sign between the two of them. Now, where does that come from? Where are they grabbing this stuff from? Well, think about this. When you multiply, what operation do you do with the exponents? Well, if you think back to what we've done, we've added exponents when we multiplied. So that's what they're doing here. When you multiply two terms, just like exponents, you're going to add them. The second one, we're going to label law 2, and we're going to refer to it again as law 2 throughout the next couple weeks. And this time they're doing not multiplying, they're dividing. So log base b of m divided by n. And again, they're just giving the m and the m a separate log, and they're putting a minus sign between the two of them. And I think, if you think about the exponents, that should sound right. If I said x to the 4th, divided by x cubed, you would subtract the exponents and get x to the 1st. So they're doing the same thing here, similar to exponents. When you divide, you want to separate the two variables by subtraction. Now the third one is the most different, and we're going to refer to that as law 3. You'll notice this time they have log base b of m to the r power. And what do? Well, they take that r power and they bring it down in front of the log. And notice we're keeping base b of m. So these are the 3 properties that we're going to refer to, again, throughout the next couple weeks. And, we're going to call them law 1, law 2, law 3. And try to, do your best to memorize these tonight. So what the heck do we do with these? Well, we're going to do 2 things. We're going to expand and condense. So our first few examples are going to deal with expanding logarithms. Now, it's very important that you read it out loud to yourself, and then that'll tell you exactly which law to use. So question 1, log base 3 of 7 times x. When those functions are next to each other, that means times, of course. So if I look at my laws, that's law 1 when I multiply. So I want you to jot down law 1 in your notebook, and we're going to apply law 1. And all that said was we're going to split up our 2 terms that are being multiplied. I'm going to give each term a log and throw a plus sign between it. So I'm going to expand this to log base 3 of 7 plus log base 3 of x. And that's it. We did exactly what we were supposed to. Again, it said 7 times x. Law 1 is for multiplication. We're just going to split those 2 up with a plus sign and give each term a log. Example 2, log of 6x cubed. Now, one thing to notice is there's no base that's straightforward to us, so we're to assume that that is a base of 10, and I'm going to go ahead and put a 10 in there. Now again, I'm going to reread what I'm taking the log of. To me it says 6 times x cubed. And since I said times, I'm going to go to law 1, that deals with times, and I'm going to apply law 1. So again, jot law 1 in your notebook, and let's apply it. Log base 10 of 6 times, turns to addition, log base 10 of x cubed. Now, in this case, we're not done because I see one more log property. And if I look at my laws, well, law 2 deals with division, and I don't see anything being divided, but law 3 deals with an exponent. And I would say this term has an exponent. So now I'm going to apply law 3. So go ahead and jot down law 3. I don't have an exponent in this first term, so I'm just going to rewrite it. Log base 10 of 6 plus, now here's law 3. That rule said take that exponent you have and bring it down in front of the log. So I'm going to say this is 3 log base 10 of x. And now I've applied all the logs that I possibly can, and I'm done. Alright, example 3. Let's make it a little more exciting. Log base 5 of 6 times x to the 2/3 times y cubed times the square root of z. Notice these are all next to each other, and I keep using that word times. So I'm going to use law 1. And again, when you see multiplication, we're going to turn that to addition. So every term gets a log, and everybody's going to get split with a plus sign. Log base 5 of x to the 2/3 plus log base 5 of y cubed plus log base 5. Now I'm going to get a little fancy with this last term. Remember, we can rewrite roots as fractional exponents. So if you recall, this is the square root, and we don't always have that 2 in that corner, but it's the square root, and roots go on the bottom, so I'm going to say that's z to the 1/2. And I'm just going to make a little note. That's what I get when I applied law 1. Now I just ask myself, are there any other laws that can take place? And I don't have any division, so we haven't used law 2 yet, but I do have exponents. So now let's apply law 3. And again, law 3 just says any exponent is going to come down in front of the log. So this first term, no exponent, I'm not going to mess with. The second term, this 2/3 is going to come down in front of the log. The third term, this 3 is going to come down in front of the log. And in my last term, my 1/2 is going to come down in front of the log. And now I have the most simplified version I can that is expanded. And by expanded, we gave every term a log, and we applied all the law properties. Example 4. I have the ln of, I'll put some parentheses there, 5x squared over y cubed. Now, this is the first time we're saying divided by. I've got 5x squared divided by y cubed. So this is the first time we're actually going to use law 2. Now, ln, we said, is very similar to log. Ln is that natural log. Its base, this time, is no longer 10. When you see an ln, it has a base of e. So let's go ahead and put our base e in there. All right, so let's start with law 2. So let's jot that down that we're using law 2. And again, we're going to expand. If I just take a quick peek at my laws over here, when I divide, I'm going to give each term a log and split them up with a minus sign. So let's say we have ln base e of 5x squared minus ln base e of y cubed. Now I'm not done. I think I can apply both properties still. And I just want to stress reading it out loud to yourself. It says the ln base e of 5 times x squared. And because I said times, I'm going to apply law 1 now. So ln base e of 5 plus ln base e of x squared minus ln base e of y cubed. And I'll make a note that was law 1. Now I'm going to go one more step and see if I can clean anything up with law 3. Law 3 says if you have any exponents, we're going to bring them down in front. So this first one's going to stay the same. The second one, I'm going to take this exponent of a 2 and bring it down in front. So 2 ln base e of x minus, I'm going to take this exponent, bring it down in front, 3 ln base e of y. And I've got my final answer there. I can't apply any more logs. None of them have a multiplication, division, or an exponent. All right, number 5 is the last example we're going to expand. So the first thing I want to do, and I'm going to make a little star here, and go ahead and do so, I want you to rewrite this. So I'm going to keep my log base 7, but remember, and I think we talked about this in a previous problem, these roots can be rewritten as fractional exponents. So I'm going to say it's 9x squared, all raised to the 1/3 power. And we said that's that groundhog rule where we take that root and we put it on the bottom of our fractional exponent. Just another thing to keep in mind, notice how I use parentheses around this 9x squared. All of this should be raised to the 1/3. So make sure you're saying all of it with the parentheses. All right, so what rule am I staring at first? Yes, this says 9 times x squared, but order of operations tell me to start with the exponent here. So I'm going to use my law 3 first. And I'm going to rewrite this as 1/3, bringing the exponent down, log base 7 of 9x squared. And I'm going to ask myself, do I have any other properties in place? Do I have multiplication or division? Well, again, just read it out loud. It says 9 times x squared. So I can break that up with addition. Now notice, it's 1/3 times all of that, so I'm going to leave my 1/3 outside. And I'm going to get log base 7 of 9 plus log base 7 of x squared. And again, I need parentheses around all of that because it's 1/3 times that quantity. Now, this one's got another step in it. I clearly don't have division, and I took care of my multiplication, but I still have an exponent. So let me just make a note that was law 1. And now I'm going to apply law 3. One more time. So law 3, because I still see an exponent, I've got my 1/3 log base 7 of 9. So this 2 is just coming down in front of this guy, plus 2 log base 7 of x. Now this answer is 100% complete. However, if it's not a multiple choice answer, there is only one other thing they could do, and I think it's common sense, you've probably guessed it. You can take this 1/3 and distribute it to these two terms. So again, this answer is 100%. If I don't see it, I'm just going to multiply each of them by 1/3, and hopefully that will be my answer. So 1/3 times 2, of course, is just 2/3 log base 7 of x. So there you have expanding. Now we can go the complete opposite way, which we're going to call condensing. So let me give you a few examples on condensing. Alright, so in condensing logs, my goal, and we'll put a little asterisk here, is to condense my logarithm into one log. Okay, I don't want to see 2, 3, 4, 5. I want everybody to condense into one log, so I'm bringing them all together. Now, I'm going to do that with my laws, but instead of looking kind of at this end of the laws, I'm now looking at the opposite end. So, again, just read it out loud, and it should really help you. I say 5 log base 4 of x. Well, if this 5 is sitting in front, that is law 3. When I have a number in front of a log, I'm just going to go backwards now. I can raise that up to the exponent. So I'm going to start myself off with law 3. I'm going to say this is log base 4 of x raised to the 5th minus log base 4 of 3. Okay, so again, I'm looking at this expanded part here, and I'm saying this r came from the exponent. So I brought my 5 up there. Now I just ask myself, okay, I see a minus sign, which means I'm now going to use law 2, the one with the minus sign. So I'll make a note, law 2. And law 2 says, this minus sign, when I put it back into one log, I'm going to write the m over the n. So I'm going to say this is 1 log base 4, and that's x to the 5th divided by 3. And there you have it. We have condensed these two logs now into one log. Now luckily there's only 3 law properties, and I think the more we use them, the more comfortable you'll get. So remember, there's one for multiplying, dividing, and then the power. So let's try another one here. So I've got the ln of 50 plus 2 ln of 1/5 plus 3 ln of x. So I'm going to start with law 3 by taking care of any exponents. So I'm not going to touch anything in the first one, ln of 50. But I am going to take this 2 and move it up to the exponent. So I'm going to get the ln of 1/5 squared plus, we got a stinker in front, we're going to move it up to the exponent, ln of x cubed. Alright, so we took care of the exponent rule, we moved everybody we could up to the top. Now I'm actually going to clean it up one more step before I touch another law property. I'm going to say this is the ln of 50, and I'm just going to clean this term up because I don't want to see 1/5 squared. Now remember, when you square a fraction, square the top, square the bottom. So you've probably guessed it, 1/25 plus the ln of x cubed. Alright, a few more steps here. I see a bunch of plus signs, and remember plus signs came from law 1, and I get addition when I was actually multiplying. So I'm going to condense all three of these into one ln, and I'm going to say it's 50 times 1 over 25 times x cubed. Okay, so again, all those plus signs in law 1 turn to multiplication. And now I'm just going to multiply these together. I've got my ln, 50 times 1 over 25 is really just 2. And I've got my x cubed. And the only last thing I can do is stick my little base on there, and I could have done that throughout the problem. Remember, in ln's, our natural log has a base of e. And we've got our final answer. We've condensed our answer into one log. Okay, example 3. 4 log base 5 of 2 minus 3 log base 5 of x. Well, I think you've had a good amount of practice. Pause me, try it on your own, and I'll work my answer out. Let's start with law 3. Take care of all these exponents. I've got log base 5 of 2 to the 4th minus log base 5 of x cubed. Alright, I'm going to clean that up one little step there. That's really log base 5, 2 to the 4th is 16, minus log base 5 of x cubed. And then I'm going to jump to law 2. Subtraction actually came from division. So log base 5 of 16 divided by x cubed. And hopefully you got the same answer. I used law 3, and then I applied law 2. And I've got myself one condensed logarithm. All right, well, it's about that time of the night. I've got one last problem for you. And again, we're condensing, because I see 3 logs. I want to condense it into 1 log. So again, if you're comfortable, pause me, do it on your own, and we'll compare. I'm going to start with law 3, all those exponent rules. And I'm going to bring my exponent up to the top there. I get log base 4 of 10 minus log base 4 of 5 to the 3rd plus. Now notice they tried to be sneaky, and hopefully didn't fall for it and put a 0.5 up there. We're smart enough to know 0.5 is actually a 1/2. So avoid decimals at all costs. Alright, so I've got law 3 taken care of. I'm going to jump into law 2 because I see division. So I'm going to condense those two into 1 log base 4. And that's going to be 10 over 5. Now remember, it's those logs cubed. Plus log base 4. And I'm going to do one other fancy thing. Hopefully you know what 9 to the 1/2 is. If you're a little uncertain, rewrite it as a root. Remember, this is the root, so I'm going to say it's the square root of 9. And so I'm going to clean that up one more step. I really have log base 4. 10 divided by 5 is 2, and 2 cubed is 8. Plus log base 4, the square root of 9 is really 3. And lastly, I'm just going to apply law 1. When I see addition, that's just telling me I'm going to multiply those two. So I've got log base 4 of 24. So all of that nonsense in the beginning actually cleaned up to this really nice simple log base 4 of 24. So hopefully you followed me today. If you didn't, come with some good questions tomorrow. We look forward to seeing you in class. Have a great night.